Okay, we just have a few more minutes to wrap up this lesson. I want to look at powers of I. So I is just I is the square root of -1, and we know that I squared is -1. So what about I cubed? So let's think of I cubed as I squared times I to the first. So that means it would be -1 times I, and we can just call that -I. What about I to the fourth? That would be I squared times I squared, -1 times -1, and that would be +1. Okay, now we're going to discover a pattern. So what if you had I to the fifth power? You could think of that as I to the fourth power times I, and that's 1 times I, and that's I. So I to the fifth power is equivalent to I itself. What about I to the sixth power? You could think of that as I to the fourth power times I squared, and so that is just 1 times -1, -1. So I to the sixth power is equivalent to I squared. I to the seventh, you could think of as I to the fourth times I cubed. So that's going to be 1 times whatever I cubed was, so that's -I. So these two are the same. And then I to the eighth is I to the fourth times I to the fourth, and that's just 1 times 1, that's 1. So we have the same cycle of 4 answers repeated. So what if you had I to the 12th? That would be another 4 down. I to the 12th would be the same as I to the 8th and I to the 4th. I to the 16th would be the same as those. I to the 20th would be the same as those. So I to the any multiple of 4 is going to be the same as those. So we can find any power of I if we think about it that way. I to the 41st, you could think of that as I to the 40th times I to the first, and I to the 40th, since 40 is a multiple of 4, is just 1. So that would be equivalent to I. I to the 102nd, you could think of that as I to the 100th times I to the second, since 100 is a multiple of 4, and I to any multiple of 4 is 1. So we have 1 times I squared, so that's going to be -1. I to the 99th, well, we could think of that as I to the 96th times I to the third, and I to the 96th is going to be 1, so I to the third is just -I. I to the 800th, 800 is a multiple of 4, so that's just 1. Okay, there's a couple more little things. We can actually plot complex numbers if we have a real axis and an imaginary axis. So here, x is my real axis, y is my imaginary axis. So it's not real versus real, as it typically would be, it's real versus imaginary. So if you wanted to plot the point 4 plus, or plot the number, I should say, 4 plus 2y, you're going to think of it as the point 4, 2. So over 4 up 2. And if you wanted to plot the number -1 plus 3i, then you could think of that as the point -1, 3. If you had something like -4i, think of that as 0, -4. So it's purely imaginary, and there it is just on the imaginary axis. So any purely imaginary number would fall on the imaginary axis. And then 2 minus 2i, think of that as 2, -2. Okay, so rather than these numbers being on a number line, they're on a number plane. And so if you wanted to talk about the distance of each of these numbers, you have to think of it as the distance from the origin instead of the distance from 0. So we're going to look at that last. So the last thing we have in this lesson is absolute value. Thinking of absolute value as distance from 0, typically, but in this case, the absolute value of a complex number would be distance from the origin. So it would be this distance here. And maybe we call that something like z. Well, if you know the horizontal distance, which would be a, that color doesn't show up very well, and you know the vertical distance, which would be b, you have yourself a little right triangle. And so to get z, according to the Pythagorean theorem, a squared plus b squared equals z squared, the way I've labeled it. So z would be the square root of a squared plus b squared. This is basically your distance formula. And of course I didn't put plus or minus in front of it because we know that distance needs to be positive. So we use the absolute value marks and we say the distance from the point a plus bi to 0 is the square root of a squared plus b squared. So let's do this last example. What is the distance from the origin to the point 5 minus 12i? So what is its absolute value, in other words? That would be the square root of 5 squared plus negative 12 squared. And so that's going to be square root 25 plus 144, sorry, and that's the square root of 169, and that's 13. Of course, it's not always going to be a whole number, but this one worked out that way. Okay, so we have explored all kinds of things about complex numbers. This may have been your first time ever to learn about the number I and complex numbers. So this little diagram here represents a circuit with resistors in it, and I can't remember what this thing is called. Some kind of circuit piece. We'll call it a piece. I'm not very electronically minded. Here is your homework from section 4.6. Sorry I don't have the page number recorded, but you'll find it. And we're doing 7 through 67 odd. And that sounds like a lot of problems, but most of them go pretty quickly. They're real short problems. There are a couple of challenge ones in there. So thanks everybody.